Okay, welcome back to the Dublin Academy of Maths online. Okay, so that's www.dublinacademyonline.com. Okay, all the W's, 3 of them only. Now today it's Leaving Cert Ordinary Level Maths in Series 5 and it's Episode 8 and we're doing Paper 1 and it's sequences and series, but we're doing geometric series. Okay, so geometric is multiplication or division by a term, by a common or ratio. Okay, ratio, ors. Now, to show that GS is constant, you put the previous one, you put the second one over the previous one, and if it's equal to a constant, then the answer is equal to, it's a geometric series. Now let me see that again. So if you have a series like this to prove that it's a, you will put this over that. Okay, and you define the or. Okay, so you define the or, you would always put the second term over the first term. Okay, or the previous term. Now this is a question here. Now I'm just going to look at this quickly. Now I just want you to remember this. So if you get a constant, you know that the GS, it's a GS. Okay, so that's a proof now. Okay, so remember that. Lots of formulas in this one. If T1, T2, T3 are a geometric series, find X. Okay, or a geometric sequence. It doesn't really matter in this case. Now remember that T1, T2, and you've got these. Okay, so T2 over T1 is equal to T3 over T2. A plus C is equal to 2 times B. Okay, and B is the mean of us. Okay, geometric series. Okay, so we know that we can find the middle term by using this formula. Okay, we're missing B, we can find B, and B is the average. Mean is the average. Okay. Now, and in this case, geometric series, it seems to be something similar. Okay, except you put the one over the other. Okay, this is similar. Okay, that means that they're similar, but this is adding and subtracting. This is division and multiplication included. So now let's get back to this question. So remember that triangle. That triangle will help you. Okay, that triangle is related to, as I said before, it's related to this side. If you had just x and you had 2 and you had 4 and you had 6, you would be able to find this side, the length of this line. Okay, by fractions, by ratio of fractions. Okay, so we're given this question. So we say, so in this case it would be the same as T2 over T1 is equal to T4 over T3. Okay, and then you would solve out the equation. Okay, now quickly solved it, and it's where is it? Okay, now you can solve it yourself, right? Because it's a kind of a, it goes on, but you see what happens here. So it would be x over T1, which is equal to 2, is equal to T4 4.5 over T3. So that'd be x over T3. 4.5. Okay, actually it's the other way around. It's T3 over 4, but you can have a look at that and you will see that it's 4.5 over x. Okay, and then you cross multiply and you get x squared is equal to 2 times 4.5. X is equal to the square root of 9. Okay, which is equal to 3. Right, so it's plus 3 in this case, right, because we don't take negatives. So that's what x is equal to, and then you can be able to find the other term. Alright, so there you go. Now let's get back to the other next part of it is now we're going to deal with the sum of. Okay, so sum of is equal to a times r to the power of n minus 1 all over r minus 1. Now this is when it's greater than 1. Okay, now that means when the constant is greater than 1, or is greater than 1. Okay, now there is a reverse for this when it's less than, and it's written around this different way, and it's just, you just change the inside of the brackets and it becomes 1 minus r to the power of n all over 1 minus r. Okay, that's when r is less than 1. That means that the difference, the constant ratio that you multiply each term by, T1 by, to get T2, it has to be it's less, if it's less than 1, you use this formula, and if it's greater than 1, you use this formula, right? They'll let you know where r is and whatever r is greater than 1. Now it says to find the sum of, so this is dealing with the sum of all the terms now, okay? Like the t, we had the last one, the tn is a times r to the power of n minus 1. Do you remember that? Okay. So we have to know our formulas and we have to find things out. So we well, let's go ahead and do a question. Find s of n. That's the sum of these. Say for example, so now they would write it 2, 6 plus 8n. Now they write it like that, but it is a series. This is the series, but you have to realize that when they're dealing with s and n's, they seem that's the sum of the of the terms. Okay, of all the terms, the same as the tn of it. When we were doing the sum of the tn terms, the arithmetic terms. So we've got 2, 6, 18, and okay, so now we put in our values. So a is equal to 2, and then r is equal to, r is the common difference, okay, common ratio. What's the common ratio? What do I multiply 2 by to get 6? I multiply it by 3. What do I multiply 6 by 3 to get 18? So the common difference, common is 3, the common ratio is 3, okay? And then I just put them into my formula, and I know the formula, I'm using the formula up here, so that's a, and I'm putting them in, so that's 2 times r, which is 3 to the power of n minus 1, all over r 3 minus 1, okay? So this is what the s of n is equal to, this sum of, so you're given a general formula to tell you at what point would they all add up to be. In other words, if I go to T40, so I know them all going up here and I go to T40, what is T40 going to give me? What's the sum all they're going to add up? Well, this formula will decide that for you. So this becomes 2 to the power of 3 to the power of n minus 1 all over 2. This 2 cancels and I'm left with 3 to the power of n minus 1. And that's your general formula, okay? So it says find, it would say find s, the next part of it says find s of 5. Okay, so find s of 5. So that's the next part, find s of 5. So now you've simplified your formula. You know that the formula here, so the new formula is out here is going to be equal to minus 1. Now don't get confused with n minus 1 up to the top. It's 3 to the power of n minus 1. Now you can't take the 1 away from the 3, okay? You have to solve the powers before you use the hierarchy of maths. I know you wouldn't do anything like that. Okay, so you put in, so this is your formula, 3 to the power of n minus 1. So you put in 5, 3 to the power of 5 minus 1. And you'd actually leave it at that answer. Okay, so you'd say s of 5 is equal to this, because they don't want to deal with large numbers. Okay, those days are gone. Okay, they want to see can you do anything with them, cancel them, you know, put them into simpler forms. Okay, now that's good. Now in a geometric sequence, Tn is equal to 3 to the power of n minus 2. Now this is a geometric sequence. Okay, so it's a GS. Okay, it says right, it says in a geometric sequence, find the first term. Find the first term, T1, okay, that's the way they would write it, and the common ratio. The common ratio is the r, which you multiply it by r, okay, and an expression for s of n, and expression for s of n. Okay, so you've got 3 things down here, okay? Now, you've got your expression here, okay? So you're going to find your terms, okay? And then when we find our terms, we can start putting them into the g of s. So I'm going to find my terms first. So Tn is equal to 3 to the power of n minus 2. Okay, so I'm just going to keep going down and find my terms. So T of 1 is equal to 3 to the power of 1 minus 2, which is equal to 3 to the power of minus 1, which is equal to a third. Now I hope you get that. Okay, 1 minus 2. Okay, you're following the formula here. And so that's your first term, a third. And then you get T of 2. And you put them into your formula, and it goes 3 to the power of 2 minus 2 is equal to 3 to the power of 0. Anything to the power of 0 is equal to 1. Okay? And you know this from indices rules is equal to 3 to the power of 3. Put n for 3 minus 2, and that's equal to 3 to the power of 1, which is equal to 3. Okay, so there is my what you call my series for this is my arithmetic series because it's Tn. Okay, so you've got your series now. Okay, so we've got, let's write in the series. So you got a third. Let's write it up here somewhere. So you got a third, 1 and 3 now. Okay, so that's a Tn. That's your Tn. Okay. Right, so let's rub this out now. Okay, now the next part says, so now you have your series. Okay, now you have to find the first term, and you've done that, the common ratio R. Okay, so now you have to change this, so now you have to get the Sn of it, okay, because it's the expressive of S of n. Okay, so Sn, so let's go, Sn will be equal to, and the constant is greater than 1, as it said, it would have said this. Okay, so I'm writing out my formula. A times r to the power of n minus 1 all over r minus 1. Okay, let's have a look at that formula. Okay, yeah, so that's what my S of n is equal to, right? And we know that A is equal to a third, right? That's the first term, and anyway, okay, so A is a third, and R is equal to 3. Now, why is it 3? Okay, because look at this progression, right? It's 3 times 3. 3 times a third is 1. 3 ones is 3. So my ratio, my common ratio is 3. Okay, so I've now changed this expression into an S and N, and I'm going to try, and I've found my R and my A, and I'm slotting them in. Okay, third times R, which is 3 to the power of n minus 1, all over R minus 1, which is 3 minus 1, which is 2. Okay, so that would be, so 3 minus 1, and now I look at this, and this is a third times 3 to the power of n minus 1 multiplied by, so it's divided by a half. Okay, so that's 3 minus 2. It's divided by 2. Okay, so it's divided by 2 over 1. So that means it's multiplied by 1 over 2. Okay, 2 3s are 6. So it's 1 over 6 times 3 to the power of n minus 1. And that's the new S of n. That's the sum of that series. Okay, the sum of that series is explained as this. Okay. Now, you have to remember that manipulating formula, which is on series 1 algebra. I think it's algebra series 1 anyway. It's in algebra. It's quite a big series. It's on YouTube. It's free to download. Anyway, so where are we at? So this is quite a good lot of work to be done. Okay, so really what you want to be able to do now is to be able to decide yourself, what is a Tn, what is an Sn, what's a geometric series, what's an arithmetic series, what's a Tn, what's this GS, okay, our S of n, and then we've got Tn of also, and we've got S of n of this as well, of an arithmetic series. Okay, so we've got the sum of them, we got difference and multiplication, right? So you have to figure out the two and go back over your notes and have a look so you know your formulas. You've got four formulas, okay, to remember. Now let's have a look at these questions. Right, there's a bit on electricity here, right? So express as Sn and the sum of the terms, the GS, and find S of 20. Okay, so you can see the terms here. 3 3s are 9, 3 9s are 27, so you know what R is and you know what A is, and then you can put them into a formula. You know the formula for S of n is equal to A times R. Okay, so the R is greater than 1, so you don't have, then this one is okay, now this is different. It might be different. This is greater than 1, or what? It's divided by 3. Anyway, anyway, we can have a look at this closer. In a geometric sequence, Tn is equal to 3 to the power of n minus 2. Okay, now don't get too confused about Tn's and Gn's. Just remember that you know your values, how you can put them in. Find A. Well, find T of 1 and then find T of 2. Find the difference or the common ratio, and then you can find R. Okay, which of the following is an arithmetic series? Okay, so this is a revision, right? And hence find T of 15. Okay, so work out your formula and then slot them in and find T of 15. Right, I hope that's everything for you. Now I can't stress now, plenty of to do these questions. Okay, that's a lot. Right.